When we look at acidification and its negative impacts, one place comes to mind, that being the Chesapeake Bay. For years, the bay has faced serious problems with nutrient runoff. This problem is known to help the acidification process. Acidification inhibits certain marine life to build calcium shells or skeletons. This threat to marine life creates a chain reaction of problems. The bay is a key spot for the fishing industry on the East Coast, and this could jeopardize that industry. The bay is the final stop for mass amounts of water coming down from rivers and streams along the northeast. Rivers like the Susquehanna that trail along strips of rich farmland are full of runoff. These nutrients get dumped into the bay, causing algae blooms and acidification. Just like in the Chapter 13 readings, it states, in brief, nutrient loading typically promotes phytoplankton blooms, which, when they die, are consumed by bacteria. Bacteria respire CO2, and thus bacterial blooms can result in acidification, events whose intensity depends on local hydrographic conditions, including water columns, stratification, and residence time. Environmental change in this area lies below the surface of the water. With the bay still being a freshwater source, coral isn't popular, but grass on the floor of the bay is. Algae blooms cover the surface of the water, taking away sunlight necessary for the shallow water plants that require the same light to complete photosynthesis. Those plants can act as shelter and food for multiple organisms. This slowly creates a crumbling food chain. As the food chain crumbles, so do the communities around the bay that rely on fishing and that for food. Reducing runoff into streams and into the bay is the best way to stop this, as well as planting more seagrass to help filter the water for anything else like CO2 and to help minimize acidification as well. This will help replenish the ecosystem in the bay.